Good morning to all of you here. Welcome to our presentations in the ACS 4 meeting 2020 that's held online. Our presentation is on Bridges to the Future towards future-ready graduates in chemistry laboratory. I'm Fuman and I'm from the National University of Singapore, Department of Chemistry, and with me today, Simon.
My name is Simon Watts. When this work was done, I was in the Department of Chemistry at NUS and the Natural Environmental Research Institute. However, this morning is interesting because I'm recording this in New Zealand, where I'm now the director of BOE. Fun Man is in Singapore recording this, and you are watching it in the United States.
And so our presentation is very succinct and short, but if you want to go deeper to the details of the stories, feel free to do a scan of this QR code. It's published in the ACS Journal of Chemical Educations with the same title here, so feel free to enjoy it and contact us if you have any questions. So the research question for our project is really about, should laboratory work still be part of our current undergraduate chemistry curriculum? Is it still relevant? Now note that this project started before the coronavirus, right? And we already think about that question here when there's still proper lab. And why we thought about that question was that because for all the years since I was undergrad or before that, we find that more of these, our chemistry undergraduate students, when they graduate from our course, more than half of them do not use any of the chemistry knowledge they learned from the curriculum. And only half of them become teachers, scientists, research, or they go on higher fields that utilize the chemistry training. And we are thinking about, are the laboratory training still useful for whichever career they want to pursue? Because if you're able to instill more training in certain kinds of transferable skills, like the analytical skills, this could be very useful in careers that's not even pertaining to chemistry, which we are happy about. And the thing is, in the curriculum that's certified by the Royal Society of Chemistry, a huge proportion of time on the lab only focus on the laboratory skills, the experimental skills that about half of these students might not benefit in the future. We had a discussion and we asked ourselves, are there specific part of our laboratory training that are preparing our students for the future? And we started to investigate and we base it on the Kolb's experiential learning cycle.
Yes, I guess most of you will recognize the Kolb's experiential learning cycle. We evolved it a little, looking at other work in the literature on learning in chemistry, and particularly learning in practical work. And so this is a slightly different Kolb's cycle to one you may have seen previously. However, we think that it's consistent with the literature and provides us as practitioners clearer thinking as we facilitate the learning in our students. Okay, so we focused this study on an advanced chemistry practical module, which included analytical and physical chemistry. I won't bore you with the details here. The module details are in the left-hand corner, and the lower left-hand corner tells you the types of scaffolding that we used to deliver this module. We supported the module by e-lectures. Our main assessment was laboratory notebooks, not repetitive experimental write-ups. Other assessments, we had one write-up which was quite radical. When we took the module over, there were many write-ups. A presentation, a viva voce examination, actually done in the laboratory, which is an interesting thing, and an unseen examination.
We associate the Kolb's learning cycle, the 4 components, right, into the different assessment methods and the teaching activities in the CM3292, our modules here, right? So in the revamped curriculum, instead of being more didactic of teaching them instructions how to execute an experiment, we give them more autonomy to plan, prepare, and think about why are they doing some experiment, and we let them come up with their own research question, because we are training them to think critically and have more analytical skills. And we find that if it is more being directed and to do something here, people's creativity, freedom, or thinking ability is a bit diminished, right? So, and the other thing is, right, we and it spouts a lot of a collaborative effort here. So they always work in a buddy-buddy, and that forces a lot of the teamwork, that these are the skills they need in the future as well. And of course, with a bit of time pressure, with a bit of little stress, it's also preparing them for the future, where in the workplace, you can't just dilly-dally or take your own sweet time here.
The interventions were that we modified the number of write-ups that students were required to do. We modified the weighting of the notebook, and you can see in the initial run there was no notebook because the notebook had a 0 assessment weighting, and also the weighting of the Viva Voce examination. Unfortunately, when you change one component of the assessment plan, by definition you change all of them. So we had to think quite carefully about a methodology of changing which will allow us to interpret the results afterwards. So this study really involves 3 independent lines of evidence to assess the impact of our interventions. One of them, which I'll talk about in a moment, is staff feedback on students in labs. So using their professional experience to assess how much the students were coming to grips with the material and the various techniques. The other 2 lines of evidence, are student perceptions of their own progress, typically questionnaires, and of course marks. So if we think about this first staff feedback, basically we used a 4-scale Likert scale, which means that there wasn't a place in the middle to hide. You had to go one way or the other. And we had 4 options then, which went from strongly agree down to strongly disagree. There were 10 staff who could have responded to this questionnaire. In fact, only 5 did. And that means statistically, we didn't expect to be able to do very much with this. Anyway, shall we go on to the results?
Yeah.
One of the characteristics of this module was we tried to introduce Socratic questioning in all of the sessions. So that's about if somebody asks you a question, rather than simply answering it, we explore with the students what those answers might be. Now, in this module, the way it's organized, we have physical chemistry and analytical chemistry practicals occurring in parallel at the same times. So on any particular lab session, there's actually 1 analytical and 1 physical session running. Now, this is really interesting and we didn't expect this. What we found, you can see the graph, the blue responses are from the analytical side and the orange responses are from the physical side. Interestingly, even with the low numbers, the analytical side has a higher score than the physical side at statistically significant at 95%. And more than that, it's also larger, higher. Not only is it different, but it's higher than the physical scores, which we found was very interesting. And I suppose it tells us something about how the different sides of the module implemented this difference, because this is a very, as a student experiencing it, this was a very different module to what had gone before. And we were curious to know, sounds very cynical, had they noticed? And clearly they had. Fun man.
And so now on this slide, we see all the survey questions from our students who took the course here. Right, Simon, will elaborate more.
Okay, again, we used a Likert scale, but this time we were trying to be kinder and we left them the middle space so they could always hedge their bets in the middle. We've used standard abbreviations on the right. So X is the standard
mean?
X is the mean,
Yeah.
S is the standard deviation, and N is the sample size. And for your reference, GTA is it's what you would probably call a postgraduate teaching assistant.
Yep.
In the labs, we had academic staff and we had teaching assistants. Okay, over to you.
Yeah. So in the next slide, right, we do a plot, right? You see the axis clearly. So we had two x-axis, right? See the top is the mark scores we attribute, to the students' practical from 0 to 30, and then the bottom x-axis is the number of practicals they did over the few years. Remember, we changed the number of experiments, right? In the past, long time ago, we had like each session they come in, they do just one experiment. So if they come in for 12 times, they do 12 random experiment. And sometimes we feel that it's just too rushed, they might not learn anything. So after the revamp, we pull some of the two sessions combined into part 1, part 2 here to make it a more holistic experiment. And on the y-axis here, you see this is the average annualized, like the marks, right, attained by the students. So over, Simon.
Okay, now this is quite interesting. You should view this graph as two superimposed graphs, and I won't bore you with the interesting way we had to form this graph in the end. And the first obvious thing, note as well that the y-axis is inverted. So the highest marks are at the bottom of the graph and the lowest marks are at the top. So you can see that in terms of the marks per write-up, one of the design things we have control of, we change the number of marks per write-up, is, and this sounds intuitively correct anyway, inversely proportional to the number of write-ups. So that's fine, one might expect that, because everything still has to add up to the same number. But increase the number of write-ups and you decrease the annual average marks. Now, this begins to be quite interesting because this falling of the annual average mark with the number of practicals maybe implies that it's less now about student ability when you've got very many practicals and more about the pressure of just having to do so many and write them all up. So it's difficult to prove this. We're just looking at this and trying to explain, if you like, where our results might have come from. There's one other final thing, which is the red intersection point in the middle of the graph. And again, this is something that looks to be sensible, but it is something we're floating here. Could it be that this area where these curves cross, and bear in mind, this is only about this module at this time, this institution, is that intersection the effective assessment pattern for this module? That is it the most appropriate and the place to be, rather than the perfect center? Is the most effective center in student learning, allowing ability and time to come together. Anyway, Funman, over to you.
Right. So the other interesting thing, in the curriculum changes, right, we give them a cover sheet, right, for their laboratory report here. And one of the questions we ask students is, right, we ask them, how much time do you spend on this reporting? And it's very interesting result we see when we correlate, right, the amount of time they claim they spend against the score they got in the end. Simon.
Well, it's interesting, isn't it? One doesn't really see the level of difference that one might have expected. Now, there are many unknowns in here. It's not the actual hours a student spent. It's what they thought they spent.
Yeah.
And we all know that if we're doing something exciting, it goes very, very quickly. But there are some jobs that seem to last forever. Anyhow, Fun Man, over to you.
Yeah, so I recall this accident assignment that I was marking it, and then I just do some random check. On Microsoft Word, right? You can see the computer doesn't lie. So I say, oh, students spend about 12 hours on this submission here. But then when they declare 80, I'm like, what's happening here? Then I just think I just think that they might close it and do some research work, and that counted as the hours, which is fine. But I think that if you see this plot here, there's not much strong correlation between the amount of time spent and the grades here, which is a bit counterintuitive, especially in this Asian society where people always tell you work harder, you work more, right? Then you have a greater reward in terms of academics here. But I guess this is a good data we have here to tell people. It's about how
Yeah.
utilize their time.
Yes, and I'll add just one rider to that. It's quite interesting if you take the last graph as actual hours and you give students 12 practicals, suddenly how many hours they would need to do this. I just leave that neutrally. Anyway, okay, let's proceed. Okay, is this you, Fun Man, or is it me?
Oh, so you, Simon.
Okay, right. Okay, so using this same data, because we asked them in this practical cover sheet, which we'll show you later, what do they think their grade will be for this practical, their predicted grade? And what we found was actually more interesting. We found that those students who obtained very high grades systematically under-predict their grade. So they are thinking all the time, oh my goodness, I'm not going to get a good grade. And they are coming out with A pluses and A's. And the opposite at the other end of the scale. Those who achieve lower grades tend to think they're going to get really good grades for their practical. Now, this is really interesting because, and I need to be a little bit careful how I put this. Is it that those getting higher grades have a firmer grasp on reality? Or, yeah, what is it? We're not sure, but it's interesting data. Over to you, Fun Man.
I just think that there's a bit of over optimism for people who over predict the grades. I mean, this is really psychology, right, Simon? That if you think you're good enough, then you don't try harder to improve on your craft or your work here, but actually it's subpar. But people who are a little bit more pessimistic or doubt themselves more, they say, oh, okay, they should work harder to achieve certain level, but actually, they are already there. So I just think we are not very good guesser.
Mm.
Right? This is how the cover sheet look like on the student report here. So this is where they put the name, date of the experiment, right? And here you see wow, this is something quite funny, predicted grade. You notice, like what Simon's talked about, a lot of students are trying to use this we found to influence the staff to give them higher grade. Even if their work is like, that it's not that great, but there's someone they put A plus or A because, they know that we're going to pen down a grade after them. So it's a bit of psychology. Some students seem to be very clever to think that if there's a huge disparity with what they predict and what we give, I don't know, Simon, what do you think?
I do, I'm afraid, think that there is some of that. But we used this form. We were a bit sneaky, really. We basically said to students, if you want feedback on your work, fill this form in. And they did. And so we used the forms in the ways we've described, but also in terms of the feedback as an opportunity to give maybe more pointed feedback for individual students to identify for them where the strengths or weaknesses were. And this is just one example of a fairly good script. Anyway, over to you, Fun Man.
Yeah. So I think a student gave us feedback. It was very helpful that because some of them want some critical feedback on the introductions or literature search here. So they write here, introduction. And then we look to the part with more details and we give them more comments here. That's more pertinent and they really enjoyed it. Instead of more general feedback on things that they know they know how to improve here. So this is a really helpful cover sheet for those who use it well. Number one, the conclusion is that we have organized the changes, the assessment from 2013 to 2017, right? Such that we change the percentage of the practicals we do in the laboratory for level 3000 course. We also change the number of practicals they do in the lab here, right? And we find that this change, has caused a change in the student achievement, right? In terms of not just grades, but of course the skills that they pick up from a course here, which is very consistent with the research.
Okay, we weren't looking for this, I suppose not specifically, but it may be that we found a method to identify the most effective, and we define that as efficient and appropriate assessment balance for this particular module. So this type of analysis may be a way to identify that. So one doesn't end up with students exhausted and disillusioned at the end of the module, nor the other side so full of optimism, which is not related to their actual achievement. Anyway, over.
Point number 3 here, we find that the exercise, right, that we revamp are able to have more scaffolding of the knowledge and ideas, and that resulted in a bit more focus on less on the academic, the very, very fundamental chemistry, but associate with the more feeling side, in the corpse learning cycle here, and try to make connections to the real world, how they can apply potentially in a job, in a role that's nothing about practical or lab, but it's really about thinking skills, about analysis of numbers.
Okay, number 4. Student feedback, which remember is about how students feel and think about it. It may not be reality, but indicates a perception that the lab survivors, I nearly said, the lab supervisors were more deeply involved in their learning on the more Socratic side, which is the analytical side of the module, rather than the physical side. So we weren't looking for that, but there's a surprise. Over.
Simon, we are survivors. We are the lab survivors. Point 5 here, from the data derived from the staff and students here, it does give us indication that when they do more practicals, they submit more reports here, the grades they got is lower than if they focus a bit more on a few key experiments and then they do more time, right? And on the cover sheet, as what we explained, that we asked them to predict the grade and also indicate the amount of time they think they spent here, we find that there's a very weak correlation to the prediction.
Finally, students' perception of the effectiveness of their work varies systematically.
Yeah.
The stronger underestimate their grade, the weaker overestimate. I suppose one of our thinkings here was that if you're clear with students about what you want, and you don't mix it all up with many other things, that allows students to see and show their achievement because they can be focused. There's not too much going on. The reality is these students worked a lot harder than many others. They're out in the field doing field sampling and things they'd never done before. So in fact, they had to work really hard, but that set up, if you like, the feelings around the module, we suspect. Anyway, over to you, Fung.
Yeah, I just want to wrap up to thank the colleagues, right, the laboratory technicians. Some of them just retired a couple of years ago, and then our colleagues, our instructors, teaching assistants, the students who make all this work possible, and the funding we got from the NUS CDTL. So we thank you very much for your time joining us in this short presentation. If you want to contact us, for me, I'm more social media, can follow me through Twitter, Instagram, Facebook, get connected. And then for both of us, this is our email. We'll hope for future talks, collaborations.
Cheers. Okay, take care, guys. Bye-bye.